Multiplying and dividing rational expressions. Are the steps for multiplying and dividing fractions similar to doing it with rational expressions? Well, let's see if we can take a look through this and see what's happening. When we multiply or divide fractions, we know that we have a certain steps, just like simplifying fractions do. When we simplified fractions, our plan was to factor out the greatest common factor, then look at things to cancel. Look at binomials, look at variables, look at the constants. And so basically, for multiplying, we're going to keep that same plan. Okay, so we're going to still factor out the greatest common factor and then cancel where we can. Now, our rule for dividing fractions, in general, what would we do? Well, we multiply by the reciprocal. So we're just going to take that second fraction, we're going to take the reciprocal of it and change the division sign to multiplication. And that's how we're going to be able to show our multiplying and dividing of rational expressions. So let's take a look here at a multiplying problem. Here I have x squared minus 2x minus 8 divided by x squared minus 2x minus 3. And I'm going to multiply that times x minus 3 divided by x plus 2. Well, if we factor out the two trinomials, we'll get x plus 2 and x minus 4 for the top one, and for the denominator, x minus 3 times x plus 1. Now what we do is we look for things to cancel. So we have that x plus 2 in common as well as the x minus 3 in common. So we'll cross those out. And then that will leave us with just x minus 4 times x plus 1. We have to remember that we cannot cross off these x's. These x's are part of a binomial. So because they're part of a binomial, we're going to leave them alone exactly where they are. We're not going to be able to touch them. Let's take a look at a dividing problem very quickly. Here we have x squared plus 9x plus 20 divided by x squared minus 5x plus 6, and that rational expression divided by x plus 4 divided by x minus 2. So what we're going to do is change this division problem into a multiplication problem by taking the reciprocal of the second fraction. And we're going to factor out the two trinomials. And when we do, we get x plus 4 and x plus 5 for the numerator. And for the denominator, we're going to get x minus 3 and x minus 2. We're going to cancel binomials that are alike, so we're going to get rid of the x minus 2 and the x plus 4. And remember, there must be one in the numerator and one in the denominator to cancel, because that will give us 1. And that leaves behind x plus 5 and x minus 3. So let's sit here and practice a few problems. Here we have 7n to the 5th divided by 5n squared times 10n to the 3rd divided by 14n. And let's take a moment and regroup everything. Let's put in the numerator to the left the constants or the numbers, and then after that we're going to put the variables. And the same thing down here, 5, 14 in the denominator, n squared and n. Now let's do some canceling, because now things aren't so far apart. We've kind of got them grouped. So we know that 5 will go into 5 once and it'll go into 10 two times. 7 will go into 7 once and go into 14 two times. And here we have 2 over 2. Well, we know 2 over 2 is equal to 1. So all of this went away. So far, we are equal to 1. We know that much. Now we'll take a look at our variables. Our variables would have a base of n and their exponents. Here, I have n to the 5th times n to the 3rd. We know that that's going to turn out to be n to the 8th. In the denominator, we have n squared times n, which is n to the 3rd. We still have to work this out a little bit more. If we remember, if the bases are the same, which is n, all we do in a division situation is subtract the exponent, so 8 minus 3. Well, 8 minus 3 means n to the 5th, so n to the 5th times 1 is our final answer. Let's take a look at another problem here. Here I have y minus 5 divided by 3y squared minus 3y times 2y squared divided by y squared minus 6y plus 5. So let's work together on trying to get those common factors out. So here I have y minus 5, nothing common there. But in this 3y squared minus 3y, we do have a 3y that's a common factor, the largest or greatest common factor. Leaves behind y minus 1. We're going to multiply that times 2y squared. And then in the denominator, we have this trinomial. You should remember how to factor a trinomial by using the diamond method, if not the way that you know how to factor a trinomial, and come up with two binomials. Your two binomials should be y minus 5 and y minus 1. Now that we have everything totally factored, we can cancel where we can. We have two alike binomials in y minus 5. We have no common constants. We have a 2 and a 3, so nothing's going to happen to those. But we do have a y and a y squared. So this 1y will go away, changing this exponent to 1. So what we have left is a 2y in the numerator, and in the denominator we're going to have 3 times y minus 1, and we're going to have 2 of those y minus 1, so I'm going to just put an exponent of 2. Let's take a look at another multiplication problem. 2x plus 1 divided by 2x squared minus x minus 3 times 2x minus 3. We need to remember that everything can be put over 1 so that we do have a situation where this becomes a fraction. But let's take that 2x squared minus x minus 3, and I will show you how to use the diamond on this one so that everybody remembers. We're going to take the first term, which is a 2, times that negative 3, so a times c is negative 6, and the b is negative 1. We're going to think of two numbers that when we multiply together will give us negative 6, but add together to give us negative 1. That would be negative 3 and positive 2. We're going to use this information here, this negative 3 and positive 2, and we're going to rewrite that middle term. So then we get 2x squared minus 3x plus 2x minus 3. We're going to group the first two terms together and pull out the common factor, which is 8, leaving behind 2x minus 3. Then we'd write that common binomial over here on the right, 2x minus 3, and we'd multiply that times 1 to get back to that side. Pull out the common binomial of 2x minus 3, and that would leave behind x plus 1. So let's show our factoring over here. We're going to keep this 2x plus 1 in the numerator because that's as factored as it gets. Our trinomial, factored into two binomials is 2x minus 3 and x plus 1. And we're going to multiply that times 2x minus 3, all divided by 1. We're going to cancel where we can. Here we have a binomial of 2x minus 3 and another binomial of 2x minus 3. When we simplify, we end up with 2x plus 1 divided by x plus 1. Recognize these are not identical binomials. Since they are not, this is as simple as it gets. Let's take a look at some division really quick. N minus 2 divided by 2n, and that's divided by n minus 2 divided by n plus 5. So our rule is change the division to a multiplication problem and take the reciprocal of the second fraction, or the second rational expression. Keep the first one exactly the way it is. Then what we're going to do is we're going to cancel anything that's common. So here we have an n minus 2, which will go away, and nothing else seems to cancel, so we're left with n plus 5 divided by 2n. Remember, this n here is in the denominator. That is represented as a variable. The n in the numerator is actually part of a binomial, so you won't be able to touch it, so this is our final answer. I do want to show you what this looks like sometimes on tests. They do not use the division sign. Remember, in algebra we use a fraction bar instead. So what I'm showing here on the right, this is typically how a division problem is shown. This is this division problem here rewritten in the notation that they expect to use when you're taking a test. So if you see this notation, this is really what it means. Okay, let's do one more division problem. Okay, so we'll keep that 5x squared minus 20x and divide it by x plus 5. And we're going to change the division to a multiplication and take the reciprocal of the second one. Now we need to do is find greatest common factors. I have 5x squared minus 20x. I know that 5x is the greatest common factor, leaving behind an x minus 4. That becomes x plus 5. And we're going to multiply times 1 over x minus 4. We're going to cancel where we can. The x minus 4s will go away. And then our final solution then, or I should say our final simplification, 5x divided by x plus 5. Hopefully this helps you understand a little bit more about multiplying and dividing of rational expressions.